Hey everybody, welcome back to our continuing discussion of respondent conditioning. This time we're talking about some factors that can influence respondent conditioning. Okay, first up let's talk about some factors that can influence classical or respondent conditioning. The first is the nature of the NS in the US. It's kind of a broad way of saying things, but it can mean a lot of different things. So starting with talking about the nature of the US, typically a more intense US is more effective at establishing conditioning. So you can imagine tastier food or a larger amount of food or perhaps a strongly painful stimulus is going to be better at establishing associative conditioning. Likewise, the neutral stimulus can be a better or worse candidate to become a conditioned stimulus. Generally speaking, the more salient a stimulus is, or the more sort of noticeable it is to the organism, the better. A brighter light, a louder sound, something that is clear and easy to notice is going to be a better candidate to become a conditioned stimulus. Learning will be established faster and more robustly with a highly salient stimulus. Beyond that, there are limitations to sort of like the biological capabilities of organisms and what things are easy to learn about. So, for example, it's really easy to learn that something that tastes a certain way is going to make you sick, but it would be really hard to put together an association that a light or a sound stimulus is making you ill, right? Because things that taste bad tend to make us sick, and lights tend not to have much of an impact on how we feel. So it's hard to condition things that are kind of incompatible in that way, and we'll talk about that in a little bit more detail. So next up, timing. We've already talked about this in some detail. There are these different types of conditioning. The timing of the NS in the US matters. Generally speaking, the closer they are in time, the better. And having a sort of forward conditioning approach where the neutral stimulus comes before the unconditioned stimulus is generally better, right? It helps to form a predictive relationship if the predictor is coming before the unconditioned stimulus. Just like with operant conditioning, consistency is important. You can imagine that if an NS always occurs before a US, then it's going to become a very, very good conditioned stimulus, right? If it predicts the occurrence 100% of the time. But if a conditioned stimulus only is present some of the time, or very rarely, it's going to be a less good predictor, so less robust conditioning will develop. Likewise, the number of pairings is important. More trials usually results in more robust learning, right? If you've only had an association happen once, it's not going to be a very strong association, but if it's happened 1,000 times, it gets to be very strong. Finally, the last thing I want to mention is previous exposure to the NS. You might expect that having more exposures to a neutral stimulus would make it a better candidate, but in fact the opposite is true. We'll talk about that in just a moment. Okay, so what I was just talking about, the idea that sometimes familiarity with a neutral stimulus or a potential conditioned stimulus can actually be an inhibitor, right? It can actually make it harder to learn about it in a new way. So if you have had exposure to a CS with no occurrence of an unconditioned stimulus many times, it actually makes it harder to learn about an association. So if we take something we have a lot of experience with that is a predictor of nothing in particular, and we then have that CS be a predictor for a US, so we pair these things together in time, it's likely initially going to produce a weak conditioned response, and we'll actually see slowed acquisition. It will take longer to learn that the CS is a predictor of the US. That's because of what we already know about this stimulus, right? We've encountered it many times, and it predicts nothing. And you might think, well, that's no learning at all, but actually it is learning, right? Learning that something doesn't predict the occurrence of anything in particular is still something, right? This is a safe thing that we encounter. That's not a very useful piece of information. But if suddenly we have it as a cue for something biologically relevant, we have a new memory we have to establish, and it makes it slower to learn about. We call that phenomenon latent inhibition. Okay, so I can't possibly talk about classical conditioning and different forms of learning and the suitability of various NSs and USs without talking about Garcia and Colling's bright noisy water experiment from 1966. I absolutely love this experiment. I think it's super clever. And all right, let's go through it. Okay, So we have two conditions here. In condition 1, rats will sort of learn that a taste is paired with the occurrence of an illness. In condition 2, rats will learn that light and sound predicts the occurrence of shock. Okay, so here's the setup we have for both conditions. We have a sweetened water solution that's very tasty to the rats. They like to drink it. And we have a couple of other stimuli in the cage. We have a bright light, and we have a bell that can sort of make allow some loud noise. So the rat is able to lick this tasty water in the presence of light and noise. So it's learning a couple of different things, right? There's one cue here. The water has a certain taste to it. It's sweet. And also, while I'm drinking this, there is a bright light and there's noise. So next we have the introduction of our unconditioned stimuli. Here, in the taste illness pairing condition, the rat is exposed to a small amount of radiation that will cause it to become ill. It will make the rat feel ill after being exposed to this radiation. There's no bright light or noise happening here, but the rat has just had some of that tasty water. On the other hand, in this condition here, we have the bright light and the noise going off, and while licking that tasty water, the rat will receive an electric shock. So during this condition, the rat is still drinking the water and will be receiving a shock in the presence of this light end. Okay, so what happens next is this rat here learns to avoid drinking the tasty water in the absence of light and sound, right? So even when there's no light or sound, those cues that were present during the training, he's not going to drink any of that water. But by contrast, here in the second condition with no bright light or noise, this rat is going to drink the water. And finally, in the final stage here, we've replaced the tasty water with just plain old water without that flavor present. Here, even with the bright light and the noise on, our rat is going to lick the plain water in the presence of that bright light and sound. Whereas our rat here is going to avoid drinking the plain water while these things are going off. Right? It's going to sit here and have a fear response and sort of freeze up. Okay, so why did I spend so much time talking about this old experiment? It's because it shows us something really, really cool about how much stimuli matter when it comes to associative learning like this. So you see here, in both conditions, rats had access to all of the same stimuli. Right? The water tastes the same, the bright light and the noise are going off. All of that stuff is being associated together, right? Here we have the rat receiving its radiation unconditioned stimulus in this panel, and here we have the rat being shocked in the presence of the light and noise. Okay, so here are the critical things. Here, the rat is avoiding drinking the water because it has the flavor in it. The rat has learned that when I drank this last time, I got sick. I don't want that. But here, the rat drinks the water, the plain water, right? So it says, okay, this water is safe. This won't make me sick. I can drink that. Here's the cool thing. There's this bright light and noise going off here. And remember, this was also present the first time the rat had the water that made it sick. So what has the rat done? It's associated its illness with the tasty water, not the noise, because noise and sound doesn't make you sick, but water does, right? So despite the fact that all these stimuli were here at the same time, the rat has learned the association between the flavor and the illness, not the sound and light and the illness. We have something similar down here, right? The rat is drinking tasty water when it is shocked, and these stimuli are also present when it is shocked, but the rat has no issue drinking that tasty water again later, because the rat has not associated the taste of the water with the pain it experienced. It's very unlikely that a flavor would result in physical shocking pain, but it is likely that a loud noise and a flashing light could result in a painful stimulus. So the rat has formed an association between the painful stimulus and these flashing light and bright noise, but not the water. So it suppresses its drinking in the presence of this plain water here because of the presence of the light and noise. So that's basically just a really long-winded way of explaining that the nature of the NS and the US matter, it's not all associations are equal, right? Some things are much easier to associate than others. Okay, that's it for this one. I'll see you next time.